Okay, we're trying to go through this example of a whole half marathon to perhaps help you as you do your Bluffton race data. I'm up to the relationship between age and finishing times. So I'm going to go to graph scatter plot. I'm going to put the regression line in there just for me and put the y variable in sample finishing and the sample age in the x variables and go ahead and graph that. You could kind of see again that the older I get, my time goes up. And remember, if I right click this, I can send it to Word or copy the graph and paste it into my part. Now, the second part, though, is relations between gender and finishing times. Gender is a categorical data, so I'm going to need something else here. So what I could do is I could do a dot plot, and I could do it with groups here. And so in this case, I could graph the variables of sample finishing times, and the categorical data would be my gender. And if I go ahead and graph that, I could see sort of this kind of data. The first one is the females, and the males I can make some conclusions based on that data. Remember that we had more females than males. Now let's try to estimate the average finishing time for all runners. So if we knew the average finishing time, we kind of already did that by graphing or figuring out the statistics for the data, and we found out the mean. That we just have to convert that to minutes and seconds. Now, but let's try to figure out how we might look at that. Instead of Dr. Constantine's time, I'm going to look for my daughter, Zoe Case, and I think she finished about 830 or 333rd. Let's see. Actually, I should just do a focus for Case. Casey Novak. Oops. Find the next one. Casey Novak. Casey Gilda. There's Zoe Case. 366th place for that. I want to figure out, well, what should she have gotten if I explain this? So I'm going to go to Stat and do the regression and do a fitted line plot. So my response is, well, I want to know what my time is, my sample finishing time, based on my age. And I'll do a linear regression. If I go ahead and do that, I got to do the sample age, not the sample finishing time. If I do that, I could then estimate that I could plug in, here's my 7,217, 22.78. So if I plug in 19, I could go ahead and estimate what Zoe's time would be there. And I could kind of estimate putting in different things like 50 or whatever. So all of these are based on my sample. Now, we could kind of compare, if you wanted to, what I would have for if I included all the data. So if I fitted the line plot instead of the sample time, I could have sampled the finishing time in seconds and based on the age. And you could see there's the plot. Only in this one person, this unknown person, we have to take a look at that. Can't be 0 years old and ran 7,514. But you could kind of see how this works, and I could kind of put in my equations there for the age. There's a lot you can do with Minitab. It really tells you a lot of data. Another thing that we could do that I should have told you, that comparing the relationship between gender and finishing times, we could do box plots, and again with groups. With multiple y's, and so I could graph. I'm going to do the whole thing. That's actually not what I wanted to do. I'm going to do graph dotplots, simple with groups, and I want my sample finishing time with my sample gender, and then I get sort of that was a dot plot. How come I didn't do my box plot with groups? I want the graphal sample finishing time with the categorical data of sample gender, And I could kind of compare the two, that females have a longer time. Remember the min, the first quartile, the median, the second quartile, and you can kind of hover over it and it gives you the statistics there. So those are kind of the information that you could use through this process.